Hey, it's good to see you back in this section. In our previous sections we learned about data types in R. Now, we will try to implement what we have discovered with a concept called vectors. Also, we will learn everything about what vectors do, and how we can use this in our programming. So let's get started. Imagine, your mother has asked you to go to the supermarket and buy some household stuff such as toothpaste, chips, etc. You take out your phone and store the names of all the products you want to buy from the supermarket. Similarly in R, you can store such values in variables. For example, var1 equals toothpaste, var2 equals chips, etc. What if there was a better way to store these, like in a list? This is what a vector is. For example, vector1 equals toothpaste, chips. So, instead of storing each value in different variables, we store them in a single vector. For example, vector1 equals toothpaste, chips. So, vectors are a group of elements of similar data types. For example, names of students in class, percentage scored by students, etc. Can we have the names of the students and the percentage scored in the same vector? No. One property of vectors is that they store values of the same data type. Since name is of a character type and percentage is of a double type, it cannot store both of them together. The cool thing about vectors is that we have been using them all along, but we just didn't know it yet. In R, all variable values are stored in vectors. So when a equals 1, R stores it as a vector with value 1 and size 1. Now, when we have x equals 1 2 3 4, R stores it as a vector x with values 1 2 3 4 and size 4. Let's understand this better by taking a quiz. We hope you now have a good understanding of what vectors are. Now, let's move ahead by understanding how we can declare vectors in R. Vectors can be declared in three ways. Using combine function. Using sequence. Using repetition function. Let's take them one by one to understand them better. As the name suggests, combined function will combine values and put it inside a vector. For example, I have a list of names such as Tom, Harry, John, Mike. If I want to store them inside a vector v1, I can simply write it as v1 less than C Tom, Harry, John, Mike. Now v1 is a vector of a character type. Let's look at some more examples to understand how we can create vectors using the combine function. We can use the combine function with numbers as well. For example, v2 less than c1, 2, 3, 4, 5. Now, v2 is a vector of the double type. Now here's a trick question. Can we put names and numbers in the same vector? As we learned earlier, we cannot. What if there were a way where we could? However, There is a catch. Since set here are both numbers and characters inside the same vector, there is a lot of confusion within R as to how to store it. So in such situations, R automatically stores the vector as a character type. We hope you now have a good understanding of the combine function. Let's take a quiz to understand this better. We hope you now have a good understanding of using the combine function to create a vector. Let's move to the second way of declaring a vector, which is by creating a sequence. Imagine, we need to write numbers in a sequence from 1 to 10 and create a vector for the same. So, R has provided two ways as to how this can be achieved, i.e. sequence function sec colon operator. Though both of them provide the same result, each has their own applications. Let's look at them one by one. In this method, we use sec function to declare a vector. Here, we just need to tell R from which number we want our sequence to start and with which number we want it to end. For example, if we need a sequence of numbers from 1 to 10, we can just write it as sec 1, 10. Now imagine, we need a sequence of numbers from 1 to 25 but with a gap of 3 between them. We can just write it as v1 equals sec 1, 25, 3. Here 1 is the starting number of the sequence, 25 is the end number of the sequence, and 3 is the gap or step which we need. There is another option provided by R for declaring a sequence of numbers to create a vector. This is done by using a colon operator. For example, if we need a vector v1 which has a sequence of numbers from 1 to 10, we can write it as v1 equals 110. Both the methods have their own applications. The colon method will generate a sequence from 1 to 10, but it cannot add any step or gaps inside the sequence. We usually use it inside for loops. When we need steps in our sequence, we use the sequence function. We hope you now have a good understanding of how to create a sequence for declaring a vector as well as which method to use for a particular condition. Let's take a quiz to understand this better. We hope you now have a better understanding of the sequence function. Let's move ahead to our final way of declaring a vector, which uses a repetition function. As the name suggests, this function helps in repeating a value for a mentioned number of times. So, when we need a vector which contains the same value repeatedly, we use the rep function. For example, if we need a vector v1 which should contain the number 3 repeated for 5 times, then we can write it as v1 equals rep 3, 5. Unlike with sequences, repetition works for characters as well. So, when we need a vector v2 which should contain a repeated for 5 times, then we can write it as v2 equals rep a, 5. Let's take a quiz to understand this better. We hope you had a great time understanding how to create vectors using the 3 functions. Now that we know what a vector is and how to create it, let's see how we can perform arithmetic operations on them. In real-world applications, there will come a time when we have to perform arithmetic operations on 2 different vectors. So R has a provision where it can perform arithmetic operations such as addition, subtraction, multiplication and division on 2 different vectors of either the same or different lengths. But first we need to understand the concept of indexing in vectors. Imagine a classroom full of students. Now each student in the classroom is given a unique roll number. Whenever the teacher wants to know which student bunked her class, she searches for the roll number of the student and gets the name. Similarly, in the world of R programming, we have a concept of indexing which helps us get the data based on a particular location. So, let's dive in and understand what indexing really is. Imagine, the teacher has a list of 5 students whose names are stored in a vector called name. Now she wants to know the name of the person in the 3rd position on that list. Using R, she can simply write name 3, and she will get Ralph as the result. Now, why did we study indexing in the first place? So in R, we can directly add, subtract, divide or multiply the 2 vectors. The result is based on the length of the 2 vectors, i.e. whether both the vectors are of same length or different length. Let's take it one by one to understand how the operation works. The concept for same-length vectors is that the value on the index of vector 1 will be operated with the corresponding value on the same index of vector 2 and so on. That means, index 1 of vector 1 will be operated with index 1 of vector 2. Likewise, index 2 of vector 1 will be operated with index 2 of vector 2 and so on. Let's apply this concept to our arithmetic operations to understand it better. Assume we have 2 vectors, v1 and v2, where v1 equals 87536 and v2 equals 47109, then the result for various operations would be as below. Add dot vector equals 12 14 6 3 15. Subtract dot vector equals 4043 minus 3. Multiply dot vector equals 32 49 50 54. Divide dot vector equals 215 and 0.67. We now hope that you have a clear understanding of how same-length vectors can do arithmetic operations. We learned that R matches the index values and does its operations. Now what if the 2 vector sizes are different? Will the indexing concept fail? Let's see how this can be tackled in R. For different length vectors, one vector would be small and other would be big. So, once the smaller vector reaches its last index, it restarts the cycle from index 1. From above image, we can see v1 equals 87536 and v2 equals 47. Once v2 finishes both the indexes, it restarts. So now index 3 of v1 is operated with index 1 of v2 and so on until v1 reaches its last index. Let's apply this concept to our arithmetic operations to understand this better. Assume we have two vectors, v1 and v2, where v1 equals 87536 and v2 equals 47, then the result for various operations would be as below. Add dot vector equals 12, 14, 9, 10, 10. Subtract dot vector equals 401 minus 42. Multiply dot vector equals 32, 49, 20, 21, 24. Divide dot vector equals 211.250.421.5. We hope you now have a clear understanding of how different length vectors perform arithmetic operations. Hope you now have a good grasp of the fundamentals of vector arithmetics. We have come to the end of this topic. Let's have a quick revision before we move to the next session. 1. We started by understanding what vectors are. 2. Then we used combine, sequence and repeat to create vectors. 3. We then moved to vector arithmetics, where we performed arithmetic operations on two vectors of the same size and of different sizes. Congratulations on completing the section on vectors. We hope you now have a clear understanding of what vectors are and how we can use them to code in R. Here we end our section on vectors to move to our next section on matrix.